Hi all, today we'll be discussing the LeetCode problem of the day, minimum ASCII delete sum for two strings. So here you are given two strings S1 and S2 and you have to return the lowest ASCII sum of deleted characters to make the two strings equal. So in this example, you have C as the first string and second string is eat. So to make the two strings equal with minimum ASCII deletion sum, first thing is you can always delete all the three characters here and all the three characters here, then both the strings will be empty, so they'll be equal. So in that case, your sum will be equal to s plus e plus a plus e plus a plus t, which will be something huge. But instead, if you delete s from the first string and t from the second string, then also both the strings will be equal. And this is the minimum possible ASCII sum we can achieve. And the sum in this case will be s ASCII value of s plus ASCII value of t, which is 115, and for t it is 116. So total sum will be 231, and this is the output. Now for the second input, we have first string as delete and the second string is leet. So in this case, you'll get the minimum sum if you delete d from here. This is also L. Yeah, so if you delete d from here and e in the first string, so you will delete dee from the first string. So the final string will become let. And from the second string, you will delete one of the e. So after doing this, both the strings will become let, so both are equal. And the sum for doing this is d has ASCII 100 and e has 101, 101, and e also has 101. So if you add all of them, you will get the sum as 403, which is the answer. Coming to the constraints, both string 1 and string 2 length will be from in the range from 1 to 10 power 3. And S1 and S2 will contain only lowercase English letters. Now let's go the approach. So suppose you have the input string as SEAC and the string 2 is EATC. So you are given these two strings and you have to return the minimum sum you have to delete such that both the strings will be equal. So now first thing you'll do is you can compare the last two characters of both the strings. So in this case, both are equal. So that means at the end in your answer, you don't need to delete the character C because they are already equal. So they won't affect your answer. So that means this is same as calculating the answer for these two smaller strings, which is SEA, EAT. So once we get the answer for SEA and EAT, so to that, if you add C in the both the strings, the answer remains same. So this bigger strings got reduced into two smaller substrings. So now for this, here we can see that the last two characters are not equal. So this will split into two cases. So case one is you will delete A. So you will add A to your answer. And since you have deleted the A, you will find the answer for the two new strings, which is SE and EAT. So originally you have to find the answer for SEA and EAT, and since you have decided to delete A, so by doing that you will add A to your answer, and since A is deleted, the new strings will be SE and EAT. So that means once you find the answer for SE and EAT, so to that if you just add an A, you will get the answer for the original SEA and EAT. So alternatively, you have other option where instead of deleting A, you can delete the T. So in that case, your answer will be T plus finding the answer for SEA and EA. EA because you have deleted the T, and that T you have added in your sum. So again, here as well, you can see your main problem got split into two subproblems with the smaller string. Here, the string 1 got reduced, and in this case, the string 2 got reduced. So since at this point, you have two choices and you are trying to minimize the answer. So this will give you one answer, and this might give you another answer. So out of these both, you will try to take the min of these both values. So you want the answer for this string. So you will calculate this answer. Suppose let's say this is 70, and here you'll get answer as maybe 78. So min of these two is 70. So that means answer for this case will be 70. And since for this case it is 70, the same thing will go up, because here since the last two characters are same, even if you don't need to delete them. So answer for your original string will be 70, and which you have calculated it by reducing your original problem to subproblems and solving them at the lowest level. So this is the classic problem statement for dynamic programming, where your original problem is getting reduced into subproblems. So to put it in a more technical way, so let me remove this. Yeah. So you have two strings, and yeah. So this is index I, denoting you have the entire string, and index j here denoting you the second string is you have the entire string. So here you can have two cases. So if s of I, it is s dot caret I, but just for the short form I'm just writing s of I. So if s of I is equal to s of j, so if the both characters are equal, then your answer is same as finding the answer for I minus 1, j minus 1. So I minus 1, j minus 1 will denote this string SEA till I minus 1, and the second string till j minus 1, which is this string EAT. And so that is what we have done here. So this is I. So I minus 1 will be at this A, which is I minus 1. So this is the case when both are equal. So if both are not equal, then you have two options. You can take minimum of yeah. So for this, let's move I backwards. Yeah, in the first case, both I are equal. So you're calling the same problem for I minus 1 and j minus 1. So that means now I has moved to the left. Yeah. So now I has moved here and j has moved here. And you want to find the answer for SEA and EAT, which is this. So now you see that the S of I is not equal to S of j. So you either have to delete A or you have to delete T. So if you delete A, then your answer will be ASCII value of A, which is S1 of I, plus finding the answer for string I minus 2, comma, j minus 1. So here it will be just I minus 1 and j. So I'll just explain this how this is happening. And if you delete T, that means you're adding S2 of j to your answer, and you have to find your answer for this subproblem, which is SEA and EA. So for SEA, you have I, and for EA, you will do j minus 1. So what this is in this you have two choices. You can delete A or you can delete T. If you choose to delete A, in this case you choose to delete S of I. So S1 of I you will add it to your answer. So once you delete this, your new subproblem will be to finding the answer for EAT and SE. So that's what we have done here. You are calling for I minus 1, which will denote SE, and J will denote EAT. And similarly, for this case, you want to delete T, so T you will add it to your answer. So once T is deleted, you want to find your answer for SEA and EA. So SEA is denoted by I, and J minus 1 will denote string until EA. So that's it. In each DP state, you have two choices. If the string is same, you will just return the whatever answer is for I minus 1, J minus 1. And if the string is not same, you will return the minimum of either this or this. And in this, for every DP, we will have a base case. So the base case for this can be, in the first string, you will have empty. That means you can say I is less than 0. And in the second string, also it is empty. J is less than 0. That means both strings are empty. So your answer will be 0. And there is another base case where only I is less than 0 and J has some value. Suppose J is, let's say, EA. So in this case, your answer will be the sum of the string EA. And in case where uh, J is 0, J is less than 0, and you have some string in the first string, let's say SE A. So in this case, the answer will be just sum of S plus E plus A. So this will be SEA. And here you will have answer as EA. So these are the base cases when either I or J is less than 0. If both are positive, then we will use this transition to get the answer. Now let's quickly code the approach. So first let me take size of both the strings. And one is s1 dot length and m will be dot length. So here we need to take a DP table of size n cross m, because for each state I comma j, we are either going to I minus 1 j minus 1 or I minus 1 j or I j minus 1. So this you can have repetitive computations of the states. So to avoid that, you can store the answer for each state in the DP table. So let's just create a DP table. Size will be n into m. And initially we want to fill the DP table with all minus ones. So I'll just iterate on all the rows, and I can use arrays.fill DP of I comma minus 1. So each row by row, I'm filling them with minus 1. So once this is done, I just want to return the answer for DP of n minus 1, m minus 1. So m minus 1, okay, let me write this again. This SE A C E A E and C. So n minus 1 is this and m minus 1 is this. So I'll return answer for the entire string of entire first string and the entire second string. And I'll also need to pass the strings s1, s2 and the DP table. So now let's quickly fill the DP function. So we have I, J, string s1, string s2 and the DP table. So let's go over the base cases later. Let's first fill the transitions. So if s1 dot char at I is equal to s2 dot char at j, then you will simply return dp of I minus 1, j minus 1. And you also need to pass s1, s2, and dp every time. Now, if s1 and s2 are not same, in that case, you will return math.min. So again, you have two options here, like we discussed. So s1 dot char at I plus dp of I minus 1, j. Again, you need to pass s1, s2, dp. So this is one option, case 1. So case 2 is this, s2 of j plus I j minus 1. So case 2 will be s2 dot char at j plus dp of I and j minus 1. So the minimum of both these states is what you'll return. And whenever you find the answer, you want to immediately store it in your db table. So before returning, you will just write dp of I j equal to this answer. And the same thing goes here as well. We move this a bit. Yeah. So here as well, before returning your answer, which is dp of I minus 1, j minus 1, whatever answer you get, you're first storing it in dp of ij, and then you're returning. So that's all is it, transitions. Now only thing left is the base cases. So the first base case, if I is less than 0 and j is less than 0, that means both are empty strings. And if you have two empty strings, then you don't have to delete anything, they are already same. So you can just return 0. Now comes the case where if I is less than 0, I is less than 0. So if this case fails and still you see that I is less than 0, that means j must be greater than or equal to 0. So this is the case where, like we discussed, in the first string you don't have anything, and in the second string you have, suppose, EATC. In that, if you have j equal to 2, so your string is until this part, 0, 1, 2. So in this case, your answer will be all the sum of all the characters from index 0 to index 2. So in this case, you can run a while loop or a for loop to iterate on all the characters from index 0 until index j and add the sum. And suppose in future you get another case where here it is 0, EATC, and here you have j equal to 1. That means j is here. So in this case also, again, you're iterating on the same string from index 0 to index 1 to find the sum. So here we can see that you are having a duplicate. You will iterate on the same string multiple times to get the sum. So instead of doing that, we can just compute the pre-compute the sum of this string. That means, so yeah. So that means you have the string EATC. So in the first value, okay, let me write it a bit bigger. EATC. You will create an array of size 4. So in index 0, you'll compute the ASCII sum of just E. And in index 1, you will compute the sum of E plus A. And here you'll compute E plus A plus T. And in the last one, you'll compute the answer for the entire string, which is E plus A plus T plus C. So once you have this array pre-computed, so whenever you have a case where I is less than 0 and j is something greater than something, j is greater than equal to 0. So let's say j equal to 2. So j equal to 2 denotes this t. So previously you have to iterate from index 0 to index t and get the sum. So now instead of doing that, since you have the array already pre-computed, you'll just check the index at j equal to 2, and that there you will find your answer. So for that, let's just pre-compute the answer for both string 1 and string 2. beforehand. So I'll take someone. Okay, since I'll be doing the same process for both the strings, I'll just create a function which can do it for me. Refill. So here I'll just pass a string. So based on the string, I'll first create an array, sum. The length will be string.length. So the first character, you will directly have to fill it. So sum of 0 will be at 0. And for the other string, other values, equal to 1, I less than dot length, I plus plus. You will have sum of I equal to sum of I minus 1 plus s dot char at I. So this is the same as the prefix sum concept. Sum of this is equal to the previous sum plus the current character. So this is how you pre-compute the sum for a string. So here I'll call the prefill and I'll pass string 1. So the same function, I can use it to prefill for the second string as well. So sum2 will be prefill of s2. And we have prefilled both s1 and s2. So I also have to pass the value in the dp function. So sum1 and sum2. And here as well, I need to create sum1 and this will be sum2 out of page. And since you have extra 2 parameters, so whenever you call the dp function, you also need to pass sum1 and sum2. So same goes here and here. So because now since we have the sum1 and sum2, we can easily fill this base case. So if I is less than 0, that means j must be greater than or equal to 0. So you just return the sum2 of j. And similarly, if j is less than 0, that means I must be greater than or equal to 0. So we'll return sum1 of I. So these are the base cases and this is the transition. So let me just test it if I have any syntax errors. Okay. Yeah, I have prefilled the sum and I just have to return the sum array. Okay, let's see now. Somewhere it's going out of bound. Okay, here. So the issue here is I'm passing both S2 and S2 here instead of S1 and S2. So due to that, the string size might be decreased. And also one more thing, before we even calculate the answer, we first check whether we have already calculated the answer in our DP table. So if dp of I and j is not equal to -1, that means we already have calculated the answer for this state I comma j. So we can also directly return dp of I j. So this is also one of the base cases. Let me just write it here. Let me test now. Yeah, yeah, and it works. Finally, let's do the time and space complexity analysis. So coming to the time complexity, here you are iterating on each row and you're trying to fill the DP table, and filling this will be order of and you're doing it n times. So this will be total order of n into m. It is straightforward because you're trying to fill the entire grid with -1s. And after that, you're calling the dp function. So this dp function is recursive, but since you're trying to minimize the states. So the maximum it can run is for n values of I and m values of j. That means the time complexity of this dp function will be again order of n into m. And I think before that we are also doing a prefill. So this prefill will be order of n and this will be order of m. So total time complexity will be order of n plus m plus n into m. So since n into m is dominant, we don't need to specifically mention n plus m. So overall time complexity will be n into m. Now coming to the space complexity, here you're creating an array of size n. So order of n space, here order of m space. But here you're creating an array of size order of n into m. So the space will be simply order of n into m. I also have the code in Python. If anyone wants to view it, I'll add this, this one. I'll add this in the description as well. And let's catch up in the next video.